Hello, welcome to Scalars and Vectors problem video part 2. To start with, the first problem we have the carom board problem. So if a carom board has it has the dimensions of 4 feet by 4 feet, length by breadth, uh, and it has the queen to be struck such that it follows the path as shown. We'll be having a figure over here. So this is the carom board. Let me draw it as properly as possible for your better understanding. So we have the dimensions of a carom board over here, that has the length and the breadth. Okay, let me draw that straight for you, as straight as possible. Okay, so it has the dimensions of 4 feet, just a 4 feet, 4 feet by 4 feet, sorry. So the length 4 feet and the breadth 4 feet. So from the center the queen is struck. Now the center obviously lies the where the lines have bisected, so the lines are of 2 feet each with respect to the center and the side. So it is struck in such a way that it hits or it strikes the edge of one of the sides, the front side we can say, and it rebounds to the pocket at the other end from which it was struck. So in this case, let me name them. So the center is O, this point where it strikes is A, and the pocket is at the point B. So it follows that path OA to AB. So we need to obtain or calculate the displacement vector, the magnitude, OA vector, magnitude of OA vector, magnitude of AB vector, and finally the displacement, the net displacement of the queen from the center to the pocket, that is OB vector. So all the magnitudes need to be calculated. Here's a enlarged view of what we had drawn previously. So again, naming the points, that is O, A and B, right? And at the point B you have the pocket. You do not need the pocket every time. Now we know that it is the pocket where it is going, so we are concerned about the obtaining the magnitude. So let me divide this as I had done previously. So point O, as the line goes through the point O, the dotted line, it is exactly the uh, horizontal line crossing through the center, and a vertical line crossing through the center, right? Dropping the perpendicular on the front edge, and this entire length is 4 feet as per the question, and the other length is 4 feet as well, but considering the perpendicular bisector dropped, we have the distance to be 2 feet and 2 feet respectively in the horizontal and the vertical directions. Now we name this square or the board that we have at hand, we name it as KL, and let the okay, I take the midpoint as M, and N, the other end is obviously B, and the extreme that point I have named it as O double dash with the this point, the perpendicular dropped from A on OO dash, O double dash as O dash. So let me take this side AN to be of distance X and AM to be of length Y. So AN is equal to X and AM or MA is equal to Y. Now with the figures available to us, this total length is obviously 2 feet. So we have the value X plus Y is equal to 2 feet. Now in this case, if we consider the two parallel lines, that is OM and O dash A, so the angle MOA is equal to the angle OA O dash or O prime, because the lines OA O dash, so why? Because the lines obviously OM is or MO is parallel to AO dash. Similarly, we can consider, yes, because they are parallel, so as the queen rebounds from the edge that is given, we can say that OAO dash, the angle, will be equal to O prime AB. So this angle will be equal to this angle because it is rebounding, right? So OAO dash is equal to O dash AB, the angle. Now also we have the line AO prime to be parallel to the line NB, that is the side. So from that we can say, with the common line AB, the angle O prime AB will be equal to the angle ABN. So if we name that angle to be alpha that we had taken previously, that is MOA, so all the other angles that we have obtained till now are also equal to alpha. So as we can rewrite the what we had obtained, we take it as equation 1, that is X plus Y is equal to 2 feet. Now from the triangles, they are right angled triangles, so from the right angled triangles, the first one, that is MOMA, and we have an alpha over there, and the other triangle, the bigger one or the longer one, I should say, that is ABN, right? Or we can write it in the order of OMA. So OMA, so this is BNA, so let me write it in that order. So OMA and BNA, these two right angle triangles have a common angle alpha, that is have the angles to be of the value alpha. So tan alpha in the first triangle, that is OMA, is MA divided by the base, that is MO, and similarly in the other triangle we have it to be equal to tan alpha is equal to AN divided by NB, that is the perpendicular by the base. Now equating both these things, we know MA is equal to Y, so Y by MO is equal to half the length, that is 2. So this is Y by 2 is equal to AN, that is X divided by the greater length, that is 4. So from this we have X to be equal to 2 times of Y. Let me take it as the second equation that we have obtained. Now we use that second equation the first, so we have 2y instead of x plus y is equal to 2 feet, and from that we can find the value of y, that is equal to 3y is equal to 2 feet, so y is equal to 2 by 3 feet. So this is the value of y. Now remember, we had obtained in equation 2 that x is equal to 2y. So x now is equal to 2 times of the value of y, that is 2 by 3 feet. So that is equal to 4 by 3 feet. So now we have the values of x and y, and we can use them to obtain what was to be obtained. So OA vector, the modulus of that, the magnitude, as that is a right angle triangle. So we have OA mod is equal to OM squared and MA squared, and that is equal to 2 squared plus 2 by 3, that is the value of y, 2 by 3 squared. We need to take the root over of that, so taking the whole root over. So this equates to the value that is equal to 2 by 3 times of, let me write it above, so that is equal to 2 by 3 times of root over of 10 feet. So this is the first magnitude that we were supposed to obtain. Then the next one, that is AB, the magnitude of AB. So the vector AB has the magnitude that which can be obtained by taking the whole root over of, as that is also right angle triangle, so there is an squared plus nb squared. Now we know the value of an, that is equal to x, and x is equal to 4 by 3, so 4 by 3 squared plus nb is 4 squared taken whole root over, so we have this value to be equal to 4 by 3 root 10 feet. So this is the second value that we were supposed to obtain, and we've achieved that. And now the final vector, the final magnitude, that is the displacement, net displacement of the queen, that is the OB vector, which is along that direction. So OB vector, for OB vector we can consider the triangle O dash and O double dash and O double dash B. So it is equal to O prime O double prime squared plus O double prime B squared. So taking these square terms and taking the root over of that, we can obtain the value of OB, and that comes out to be equal to the values being 2 feet each in each case. So 2 squared plus 2 squared taken root over, we get 8 root over of 8, so that is 2 root 2 feet. Okay, so we've obtained all our answers. In the next question we have a regular hexagon to be represented in the way as shown in the figure along with the x and the y axis. Now this is a regular hexagon with, obviously, the each side has the same length, and the sides are in the form of vectors, and they are taken in the same sense. Same sense means here it is in the anti-clockwise sense, starting from the origin. So they are taken in the same sense. So the resultant of these set of vectors, resultant of all the vectors, comes out to be equal to, any guesses? Yes, so the resultant of each of the set of vectors, that is the side vectors, is equal to 0. Now as the resultant is 0, we use this data that we have, that is the resultant is equal to 0, to prove, we need to prove that cos of 0 plus cos pi by 3 plus cos 2 pi by 3 plus cos 3 pi by 3, that is pi, plus cos 4 pi by 3 plus cos 5 pi by 3 equals 0. Now this is mathematically quite clear with the values of the angles given, but we need to use the case where the resultant of all the side vectors is 0, and from that we need to prove it. So let's get going with that. So let all the sides have the magnitude a. Obviously it's a regular polygon, a regular hexagon, so all the sides have an equal magnitude, that is a, and they are in the same sense. And now the first side, that is OA, is parallel to the x-axis, so the second side A1 A2 is making an angle of 60 degree, and so on. The angles are increasing by 60 every time. So let me just consider the axis along each point that we have obtained over here. So we consider the x-axis along each point, and then we consider the y-axis along each point, so that it's easier for us to resolve these set of vectors. So we consider the x-axis as well as the y-axis along each point. So now, with all the y-axis and all the x-axis available, we can easily resolve these vectors. The first vector, resolving the vectors, each of the vector, the side vectors, that is, along x and y axis, we have, what do we have over here? That is OA vector. Actually it's OA vector. The first one is along the x-axis, so the angle is 0 with respect to the x-axis, so the sine component does not exist, but we can write that. So a cos 0 I cap, a sine 0 I cap, and then we have a1 a2 vector, a1 a2 vector, that is making an angle of 60 degree, that is pi by 3 with respect to x-axis. So a cos pi by 3 I cap, cos, and then again sine pi by 3, the vertical component along the y-axis, so there's j cap. Then a2 a3 vector, similarly we have that angle to be equal to 120 degrees with respect to the x-axis. The angle keeps on increasing by a value of pi by 3 every time, so 2 pi by 3 I cap, then a sine 2 pi by 3 j cap. Similarly we can write it for other vectors, that is the next vector, that is a3 a4, is obviously making an angle of 180 degrees with respect to the x-axis, so that is completely 180 degrees. So a cos pi I cap and a sine pi j cap. Again a4 a5 is making an angle of pi plus pi by 3, so that gives me 4 pi by 3, the total angle, that is 240 degrees. So a4 a5 vector is equal to a cos 4 pi by 3 I cap and a sine 4 pi by 3 j cap. And finally we have a5 a5o to be making an angle of 5 pi by 3 with respect to the x-axis, and finally there, so we have over there a cos 5 pi by 3 I cap, a cos 5 pi 3 I cap. Now on the left hand side, the vectors that you have, as the vectors are in the same sense, if we add all these vectors out, then as per the given value, the resultant goes to 0. This is a given. This is what we have with us. that is the resultant of all these vectors taken in the same sense. Obviously, from vector law of addition, we have them to be equal to 0. Now with a not equal to 0, in order that we get the result to be 0, all the I and the j cap components, j hat, whatever you can say, that all the I hat and j hat components have to be equal to 0. So they add up to 0, every component, because I and j are two separate axes, so they have to be individually equal to be 0. So taking the a out from each term, we now separate the I cap and the j cap terms. So we have cos 0 plus cos the second term, that is pi by 3, plus cos 2 pi by 3 plus cos 3 pi by 3, that is pi, plus cos 4 pi by 3 plus cos 5 pi by 3 with I cap taken common, plus finally we have we have to take the sine. So sine 0 plus sine pi by 3 plus sine 2 pi by 3 plus sine pi 3 pi by 3, that is, plus sine 4 pi by 3, and finally sine 5 pi by 3. Now that entire term with j cap taken common. Now each individual component of I cap and j cap, that must be equal to 0. But we are not concerned about the j cap over here. We were to prove the component of I cap, that is cosine of all the angles that we have over there, that is to be 0, and that has been proved. And we proved it by using the fact that the resultant of all the vectors is a 0. So using that, we obtain that. Till next time, thanks for watching. Bye bye.